All right, 512, multiple representations of quadratic functions. This is your tutorial video. Thanks for watching. All right, let's start with our essential question. What are we hoping to get out of this lesson? We want to know what information we can get from an equation, what information can we get from a graph, a table, and a situation, all as they pertain to quadratics and parabolas. This web right here is really what we're after. Can we make connections between tables, situations, graphs, equations? For this lesson, make sure that you have a highlighter, pink, yellow, green, marker, just something to help us keep this information organized. All right, first thing I want you to do with your team, read 5-16 and highlight important information as you go. It doesn't matter what color you highlight, just highlight important information. Go ahead and pause the video now. Let's take turns reading. Teammate 1, teammate 2, teammate 3, and then teammate 4. Why don't you read the last two here, okay? Go ahead and pause the video now. All right. Now that we've read and we understand the situation, we've got a water balloon launch happening. We got 4 contestants: magnanimous, generous, impeccable, and altruistic are competing. And we get a little bit of different information from each person's water balloon launch. We'll dive into that in a little bit. We know that Maggie gets an equation. Jen, we have a graph. Impeccable, we have the whole table. And altruistic, our computer crashes, and we've only got a few pieces of information. All right, here's your task. Here's what you're going to do with your team. For each contestant, you're going to create a table and graph. All right, so that will do on the back of this paper using the information we just read. You also want to find who launched their water balloon the longest and who had the highest water balloon launch. Once we figured out all that, you're going to come back to this side of the paper, questions 3 and 4, find the x-intercepts for each launch, as well as the vertex from each launch. So ultimately what we're after is from an equation, from a graph, from a table, from a situation, we should be able to find the x-intercepts and the vertex from each of those. All right, so I've summarized some important information here. This is the stuff that I hope you have highlighted, but it's tough to go back and forth on your paper, so I thought I'd put it right here. So Maggie, we know she placed it at the 3-yard line, and she has this equation. Jen, we're given this graph. Imp, we have this table. And Al, we've got a couple pieces of information. We know the 10-yard line. It lands at the 16-yard line, and it reaches a height of 27 yards. All right, so let's dive into Maggie's. We'll start one at a time. All right, first question I have for you is, why did I choose to start the table at 3? Why does that make sense? Well, if we look at the information, where does she launch the balloon? She launches it at the 3-yard line. So it makes sense that our first x value would be 3. Now we have this equation, and so how are we going to get the y values? Well, this is really similar to the lesson 511. We're going to plug in our x value. So negative x squared plus 17x minus 42. Again, I leave parentheses and blanks because each of these is going to go in here for our x values. Order of operations is important to consider here. So we plug in our first value, 3, and we go 3 squared. And we know 3 squared is 9. Make it negative. All right, 7 times 3. Or excuse me, 17 times 3. Okay, positive times positive, so we know this is going to be positive. We've got 51. And lastly, we're going to subtract 42. All right, negative 9 plus 51, take away 42. When we do this, we always read from left to right. Okay, so negative 9 plus 51. Negative 9 plus 51, that's the same as 51, take away 9, which gives us 42. All right, and 42 take away 42. Wait a second, that's just 0. Well, that should make some sense, because if she launches at 3, what's the height? The height is still 0. She's barely launched it from the 3-yard line. So we'd expect 4 to have a little bit bigger of a value because after we've launched it, now it's going up in the air. So let's take a look at what happens here for 4. All right, we plug in 4. 4 squared is 16, make it negative. 17 times 4, that gives us 68. Take away 42. All right, so we've got negative 16 plus 68 minus 42. This gives us 52 minus 42 when we combine. And here, that gives us a final answer of 10. All right. So I'm going to let you go ahead and finish the rest of this table. And then where do we go from here? Well, you're going to get your pink highlighter. And you're going to plot those points. First point is at 3, 0. Second point is at 4, 10. And so on and so forth. So what do you need to remember for Maggie? When we have an equation, plug in the x values to find the y values, and then plot each point. All right, let's take a look at Jen. Jen's information. Well, we have the graph. All right, well, this graph includes quite a bit of information. Well, the first point here, every point is an ordered pair. So this first point is 0, 0. That's my x, that's my y. 0, 0. Okay, my next point is at 1, 14. 1, 14. I'm going to let you fill in the rest of this table. Bottom line for Jen, each point on the graph is an ordered pair, x comma y. There's your information. All right, for Imp, we have the whole table. This one's a real breeze. All we got to do is plot these points on this graph. All right, so we've got the point 2, 0, 2, 0, the point 3 and 9, and so on and so forth. And we're going to connect these dots, remember, with a smooth U-shaped curve. All right, just plot the points. All right, and last but not least, we've got Al, and Al's is my favorite. We have such little information, and yet we can still get a pretty decent sketch of what his balloon does. All right, Al's released from the 10-yard line. Well, the 10-yard line, okay. Well, it makes sense that I'd start my table at the 10-yard line, and we know it lands at the 16-yard line. Well, think for a second. How high is it when we launch? Well, right when we launch, it has no height. It's at a height of 0. Okay, so we're at 10, 0. And when it lands, well, at the 16-yard line, when it lands, it has a height also of 0. Okay, and we know all of our parabolas have done the same shape where it goes up and then it comes back down. So where do you think it's going to reach this high point of 27? Well, it makes sense that that highest point should happen at the halfway mark. So halfway between 10 and 16 is 13. Okay, well, at 13 is when it reaches its height of 27. So I can plot that on my graph, 13 and 27, 25, 26, 27. Here we go. All right, now we don't have any other information about Imp. At this point, we can't figure out the rest of this table. We know the general shape of our graph is going to go up and come back down, but we're not sure about the other points. So we're going to leave this right there. And now we have all the information we need to finish our task. So make sure that you go back on the other side of the paper and let's finish answering our questions. So, for each contestant, have we made a table and a graph? Yes, we sure have. Okay. Have we determined which of these is the longest and the highest? I'm going to let your team talk about that. And then I want you to look through each of those graphs and tables and tell me what are the x-intercepts and where is the vertex for each participant. All right. Good luck. That's it for our water balloon launch.